Okay, now this lesson's a little bit tough. 5.3. Factor the expression completely. Big emphasis on the word completely. This is not a quadratic expression. X squared is quadratic, so you can't just depend on your ABC rules. You're going to use A, B, and C, but you can't just depend on that. You're going to apply a 1 there and underline your terms. Remember, factors to put it in as many parentheses as you possibly can. Rewrite this in as many parentheses as you can. Now, how many terms do you have? Don't label ABC yet, okay? 3 terms. That's called a trinomial. To factor a trinomial, you do GCF and then make your table right there. Now, look at your numbers. 1, 5, and 36. That'd just be 1. Does the last term have X? No, it does not. So don't put X. And the first number is positive, so the GCF's positive. So I end up with just a 1 sticking out. Don't do it. Okay, now, after that's been done, we're going to go to the ABC, even though it's not a quadratic, and we're going to take 1 times negative 36. That'd be negative 36, okay? So I need a positive times a negative, and I need the factors to add to negative 5. So I start dividing. 1 and 36, no. 36 divided by 2 is 18, no. Divide by 3, you get 12. No. Divide by 4, you get 9. Bam. Now, to check your answer, times them and see if it's negative 36. It is. Now add them. And is it negative 5? It is. So I know I'm right so far. Now, the next part you can't muck up. You need to put A equals, okay? A equals. And you need to put 1 with its x to the 4th. And all I want you to look at is that. Now, if A is a 1, you can delete it and just make 2 parentheses. But it's x to the 4th. It's not x second. It's x 4th. So you don't go x, because that's for x second. When it's x 4th, I go x second, x second. You split that in half, okay? Because splitting an x second in half is x. Splitting an x 4th is x squared, x squared. If I had x 6, I go x third, x third. Then I put the plus 4 minus 9. But you are not done at that point, okay? Didn't have a GCF. Bring these factors up here. X squared plus 4, x squared minus 9. You need to see if you have either one of these as adopts a difference of perfect squares. If it's got a plus, it's done. And you bring it down here. This is where I'm going to put the final answer. If it's got a minus, you circle it and say, gee, is 9 a perfect square? Yeah, it's 3 times 3. Is x to the second a perfect square? Yeah, that's x times x. Okay? So you make 2 parentheses, 1 plus, 1 minus, and you write that as xx plus 3 minus 3. Okay? And then you're done. That's broken down as much as it possibly can be. Okay, my next problem. We have negative 2x to the 5th plus 32x. Okay? Now, again, it's not a quadratic expression. It's higher than a quadratic. Quadratic means it's x second. When you have higher than an x second, you have to factor. You want to underline your terms and count them. That's 2 terms. 2 terms is GCF, just like the 3 terms, but now we're going to see if we have a difference of perfect squares instead of going to the T-chart. I go right to dots. And after I'm here, I'm still going to be lining stuff up here to see if I can factor further. Now, 2 and 32, those are both in the second row on the multiplication table. So you put 2. Now there's 2 more questions you got to ask. Does the last term have an x? Yes, put it down there. Is the first number negative? Yes, so the GCF's negative. Now, what you do then, put that negative 2x right here. Put it in parentheses if you want. Doesn't need to be, but just put it there. That's in the answer, so I can just forget about it right there. Now I divide by negative 2x. Now we know that cancels. Now negative 2 divided by negative 2 is 1. X to the 5th divided by x. Watch this, okay? Don't write it. X to the 5th means x times x times x times x times x divided by x. Oh, now I have x to the 4th. Okay? Positive 32 divided by negative 2 is negative 16, so minus 16. Now, you're just looking at the parentheses, just right in there. Is that adopts? Well, you got a minus. Can you write 16 as something times itself? Yeah, it's a perfect square. It's 4. So 4 times 4. You can cross out the 1. X fourth. Yeah, x second times x second. Okay? So x second plus 4 minus 4. Guys, don't put x second there. It looks stupid. Okay? Now, carry these up and see if you have any more dots. Well, the one with a plus, I know those are perfect squares, but it's called difference of perfect squares for a reason. A plus does not signal a difference. Plus drops down. Okay, then the second one, I got the minus. And 4 is 2 times 2, and x to the second is x times x. So you bet I can rewrite that in 2 parentheses. So x, 2, 2. There, that's all the factoring. I want to see all those, okay? Okay, next problem. 6x to the 3rd power. Wait a second, is that the right one? Yeah, okay. 6x to the 3rd power plus 13x to the 2nd power minus 5x, okay? Wait a second, I don't think, yeah. That's 1, 2, 3 terms, okay? So 3 terms is GCF, and then my table. Okay, so 6, 13, and 5. Yes, it's 1, but we have an x on the final term. Now the first term's positive, so the GCF's positive, but you need to go up and divide by 1x. 6 divided by 1 is 6. These cancel. The other two don't. X third divided by x. Gee, if I took x third divided by x, I'd end up with x second. Plus 13, x squared divided by x. I'd end up with x minus 5. Now go to, and also put that 1x right there. Okay, I don't have to worry about it then. ABC. 6 times negative 5 is negative 30. Okay, so it's a positive times a negative, and you're trying to add to positive 13. 1 and 30, no. Divide by 2, you get 15. Now, watch this. 2 plus negative 15 is negative 13. I need positive. Well, plus 15, negative 2, I'd have it. Now, A equals, look at your A and nothing else. This time it's not a 1, it's a 6. So you make 4 parentheses. So start with 6, 6. Now how do you break an x squared in half? Well, that's xx, okay? Minus 2 plus 15. Now in a multiplication table, those are both in row 2. 3x minus 1. What do you do with the 2? You divide it by nothing. It's gone. 6 and 15 are in the 3rd row. Okay, now bring these up here. Now the one with a plus, we just bring that down. With a minus, yeah, you have a minus, and that's 1 times 1, but 3 is not a perfect square, so we bring that down. And there it is. 1x times 2x plus 5 times 3x minus 1. Okay, next problem. X to the 4th plus 4x to the 2nd minus 12. Okay. How many terms? Again, it ain't a quadratic, so you have to count the terms. 1, 2, 3. It's a trinomial. Okay. So trinomial, same thing. GCF followed by the table. If you set up these graphic organizers, that at least gives you a good shot. 1, 4, and 12 is 1. Do you have x on the final term? No. What's your first number, negative or positive? It's positive, so it's just 1, so we're not going to go through with it, so don't put anything on the outside. 1 times negative 12 is negative 12, so it's got to be a positive times a negative, and we're adding to try to get to positive 4. 1 and 12 is not even close. Divide by 2, you get 6. Add them. That's negative 4. To make positive 4, I go plus, negative. Just switch them around. What's your A? Write that, and with its variable, 1x to the 4th. So you can disregard the 1. That tells me, okay, 2 parentheses gets it done. X 4th is split in half. The exponent's split in half. This whole number in front is not split in half, but the exponent is. So if you'd have like a 4x to the 4th, the 4 you'd keep, but the x 4th is the one you split in half. So x second. Then minus 2 plus 6. So we're going to take you guys up here and see if you can do some more factoring with the dots. The plus can't be. Okay, you just put that down. Now that's a minus, but 2's not a perfect square. No, it's not 1 times 1. 1 times 1's 1, Holmes. Okay, drop it down. It's prime. I mean, if that was a 4, definitely, but it's a 2. So that's your answer. X to the 2nd minus 2, x to the 2nd plus 6. Okay, 3 more. Negative 2x to the 4th power plus 50. That's 2 terms. Now you're back to 2 terms. 2 terms, GCF. And then you see if you have a DOPS. And once I'm done there, I'm going over here. 2 and 50, those are both in the 2nd row. Okay, both in the 2nd row. Does the last term have an x? No, so no x. Is the first term negative or positive? It's negative, so it'll be negative 2. So you put negative 2 right there, not with x, so, and then you go up and divide by negative 2. So it's going to be 1, x to the 4 stays. And then positive 50 divided by negative 2 is negative 25, so minus 25. Now, forget about the negative 2, okay? You're just looking at this. Well, you got the minus. 25 is 5 times 5. You can ignore the 1. X to the 4th is x to the 2nd times x to the 2nd. So x second plus 5 minus 5. Now, bring those up here, and we're going to talk about them. Now, on a quadratic, you never had to do that because you didn't have the issue of still having a power on your x, okay? Now, the one with the plus, that's done, okay? You can't break that down. The one with the minus, you can't either because 5's not a perfect square. So that one was done right there. Boom. If you follow the game plan, it should work. Okay, x to the 5th power minus 5x to the 3rd power plus 4x, okay? 1, 2, 3, you're back to 3 terms. So GCF and the table. 1, 5, and 4 is 1. Your final term does have x. Your first term's positive, so it'll be positive 1x. So we put 1x here. And then I go divide by it, okay? So once I put that 1x there, I forget about that. So it's 1 x fifth divided by x takes it to x to the fourth. 5 divided by 1 is 5. X third divided by x takes it to x second plus 4, and get rid of the x's there. That's a 4 I just made, okay? Now, this is what we're factoring now. 1 times 4 is 4, positive. Now we get a positive finally, so the signs must match. We're trying to add to negative 5. Well, 1 and 4. It's negative 1 plus negative 4, negative 5. Yeah, okay, it is. Does it multiply to positive 4? Yes, it does. That's right. Now, you got to focus on your A. Your A is 1x to the fourth. Well, 1, you can discard the 1. That means you just need 2 parentheses. X to the fourth is split in half. The power's split in half, okay? So x second, minus 1, minus 4. Bring those over here, okay? We need to do further inspection. When they still have powers on them, you need to inspect them. You never had to do that in the quadratic unit because they were always ended up as just x's. But when they have powers at the end, you got to inspect them. Minus 1 is 1 times 1. X is seconds. X times x. That goes down. Okay. Plus minus xx 1 1. So write those down. Now the powers are gone, so I know it's finalized. Now check the other one. You got a minus there too. Oh, 4, 2 times 2. X is second, x times x. Plus minus xx 2, 2. Okay? Bring them down. So I have all that crap, okay, factored out perfectly. 1x, x plus 1, x minus 1, x plus 2, x minus 2. So again, 2 terms GCF dots, 3 terms GCF table. Make sure you're paying attention to the exponent. Okay, last problem. 3x to the power of 5 minus 18x to the power of 4 plus 24x to the power of 3. 1, 2, 3. Okay, 3 terms. GCF table. 3, 18, and 24 are all in the third row. Look at your last term. I not only have an x, I have an x to the third. Okay? Now, first term's positive, so it'll be positive. So you put 3x to the third right there. Now go divide all of these by 3x to the third. Okay? And those will cancel. The 24 and the 3 won't, but the x surds do. So that's 1. 5 minus 3 is 2. You just subtract the powers, okay? Minus 6. 4 minus 3 is 1, but don't just put x when it's to the first, please. 24 divided by 3 is 8. That's now a constant. So, I've already placed that. Now I'm just focused on breaking this down. So 1 times 8 is 8, positive. So the signs have to match. And we're adding to negative 6. 1 and 8, no. Divide by 2, you get 4. Boom. Okay, that adds to negative 6. It multiplies to positive 8. Here, if you were concerned about the signs, multiply them. Okay. Oh, that's 8. Good. Now add them. Good. Now what is the A? A is 1x to the second. So 1 means you just need 2 parentheses to get it done. X second, split it in half, it's x first, but that's just x and x. Nobody puts a first power on x, it's just x. Minus 2, minus 4. Now, bring those over here for further inspection. Now, that's got a minus, but 2 is not a perfect square, so that's brought down. Now, be careful. That's got a minus. That's 2 times 2. But the x has no power to it. So you can't break that down either. For it to break down into perfect squares, x has to be of an even power. Okay? So that will stay the same. There we have it. Okay?